This lesson is about arithmetic series. So an arithmetic series is just when you add up the terms of an arithmetic sequence. We're going to stop with finite arithmetic series. You can't actually do the sum of an infinite arithmetic series, although we will talk about an infinite geometric series in a little bit, but not today. So the notation we're going to use is S sub n, S standing for series or sum, and then n is the number of terms in this series. And of course, what we mean is we're adding up sigma as I goes from 1 to n, a sub I. So it'll be a1 plus a2 plus a3 all the way to get to an. I is the index because we stop at n, so we can't use n in the index because that's the final term, and I starts from 1 to n. Now, of course, an AI here, I'm assuming, is an arithmetic sequence, these terms of an arithmetic sequence, which would be this, a1 plus I minus 1 times d. Again, I'm using I here, not n, because n is only the very final term. And now I'm not going to derive this formula for you. I've done it in Algebra 2, so you may recognize it. This is the sum of an arithmetic series, n times a1 plus an, all divided by 2. So a1, of course, is the first term, an is the final term of those n, the last one, and then, of course, the n is the number of terms, and then you divide by 2 to make the formula work. And if you're interested in looking at how that's done, the textbook does a decent job of explaining how they derive that formula. Now, don't stress about that right now. This is just writing the same thing in sigma notation, just in case you encounter it, so you recognize what's going on. If you see something like this, you're like, oh, okay, they're talking about an arithmetic series as opposed to a geometric, which we'll get to in a little bit. Now, you will often see this written differently. Instead of an, they'll use the formula for an, which is this one right here. So this here, the a1 plus n minus 1 times d, is exactly the same as that an, and so they'll substitute that and then combine like terms to give it to you this way. I'm not a big fan. I don't find any advantage in memorizing two formulas when one will do, so I'm going to memorize the easier formula. Now, of course, it is on the formula sheet, although it's written slightly differently, but it is on the formula sheet. So worst case scenario, you can use either this one or this one from the formula sheet. But again, I would just memorize this one if you're going to do any memorization at all, and then just remember that an is going to be the nth term, the last term of the sequence. And so if you don't know how many terms there are, you have to use the arithmetic sequence formula to work that out. So this is the one I would have you memorize, Sn equals n, a1 plus an all divided by 2. But this is another version of it, which is the one I wrote over here, Sn equals n times 2a1 plus n minus 1 times d all divided by 2. Now, of course, the formula sheet likes the letter U instead of the letter A for arithmetic or any sequence or series at all. So it'll give it to you this way, and for some reason they factor out the n over 2 in the front. Neither here nor there. So they actually give you this version first, and then the one that I prefer second. So I would just go with this one. Again, it's not very hard to memorize, so after a lot of use, you will just automatically memorize it without even thinking about it. But worst case scenario, you can look it up. All right, so let's find the sum of 4 plus 7 plus 10 plus 13, blah, 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 to 50 terms. Now, we notice, first of all, this is an arithmetic series, and I'm just going to mention that, arithmetic series. As of today, of course, it's the only type of series that we're going to be dealing with, so you may not technically need to say it. But since there's going to be another one in the next lesson, geometric series, we want to make this part of our work identifying this is the type of series that you're dealing with. Now, because we've identified as an arithmetic series, we know the formula Sn is going to be n times a1 plus an, and then all over 2. So what of this formula do I already know? Well, it said 50 terms. That's n. The number of terms is 50. A1 is the first term, so that's the 4. 2, of course, is just a number. An is the thing we don't know. Now, an represents the last term. Well, that's the 50th term. But an is the last term of a sequence. So the arithmetic sequence formula also comes into play, which is an equals a1 plus n minus 1 times d. So I also need to take advantage of this formula. So in this formula, what do I know? Well, I know a1 is the first term. I know in this case I want the 50th term, so n is going to be 50. And d is the common difference. What are we adding each time? We're adding 3. So a sub 50, which is the one we want, is a1, which was 4, plus 50 minus 1 times d, which was 3. So when I simplify that, it's 4 plus 49 times 3. So we get 151. And now we're ready to take the n, the a1, and this an, the a50 that we just figured out to work out Sn, or in this case, not Sn, but S50 is what we're actually doing. N is just going to be 50 times a1, which was 4, plus a50, which is 151, and then all divided by 2. And when I work that out on the calculator, I get 3,875. And again, don't round this. Give me the exact value when we're dealing with a sequence or a series. So that's that one. Again, what I did was I said, okay, here's the formula for the arithmetic series. Inside that is an arithmetic sequence formula as well, and I just used those two individually to work out the missing pieces for what I needed to be able to answer the question, so I could avoid the more complicated series formula, because I need that for certain problems anyway, and I might as well just memorize this easier version. All right, so here we go. Find the sum of this series. Well, first of all, recognize that it's arithmetic because you're adding 7 each time, so first thing is arithmetic series, because again, you will discover some of them will be geometric, and so you have to recognize which is which. So again, the formula for the arithmetic series is Sn equals n, a1 plus an divided by 2. What we know here is we know the a1 and we know the an, but we don't know what n itself is, so that's going to be tricky. However, once again, this an is the nth term of a sequence, so I can use the arithmetic sequence formula, an equals a1 plus quantity n minus 1 times d, and I'm going to go that way. Now you'll notice that the other formula for Sn won't actually accomplish anything here because you still don't know what n is. So again, this method allows you to do all possible scenarios without having to learn a separate unique formula for certain circumstances. So I'm going to use this again to work out what n is. I know that the nth term, the last term, is 141, equals a1 was -6 plus n minus 1 times, well, the common difference was we added 7 each time, so times 7. And basically, I need to solve for n. So here we go. I add 6 to both sides, so 147 equals 7n minus 7. Add 7 to both sides to get 154 equals 7n. When you divide both sides by 7, you get n equals 22. So now we think about our series. We know the number of terms now is 22. We know the first term is -6. We know the last term is 141, which is divided by 2. So now we have all the pieces we want. So S subscript 22, not Sn anymore, is 22 times -6 plus 141, all divided by 2. And I plug that into my calculator, and I get 1,485. So once again, I use the arithmetic series formula and the arithmetic sequence formula to work out the missing pieces. The arithmetic sequence formula is going to be the one that finds whatever's missing from the formula. If you have all three things, n, a1, and an, then you're in good shape. But generally speaking, you'll either have a1 and an and not n, or you'll have a1 and n, but not an. So you'll have to work one of those two things out. But you should be able to identify the common difference pretty easily because you'll have the first few terms, generally speaking, although not always. All right, an arithmetic series has first term 8, common difference 2. The sum of the terms of the sequence is 170. Find the number of terms in the sequence. So once again, Sn, I don't have to say arithmetic. It's already given to me, so I don't have to mention that. It's already given to me. N, A1 plus An divided by 2. Now, what do I know? I know the first term is 8. I know the common difference is 2. I know that the final sum at the end is 170. I don't know the An or n itself, because it never told me either of those. However, I have an arithmetic sequence formula, an equals a1 plus n minus 1 times d, so I can use that one to work some stuff out. Well, let's work on that one. An now, since I don't know what it is going to be a1, which was 8, plus n minus 1 times common difference 2. So if I simplify that, it's 8 plus 2n minus 2. So in other words, 2n plus 6. So I'm now going to substitute this in the an spot. And of course, I'm going to plug 170 in the Sn spot. So 170 equals n times a1 we said was 8, plus this new 2n plus 6, and then all divided by 2. So let me go ahead and combine like terms, and actually while I'm at it, also distribute n because it's easy. So I'm going to get 170 equals 8 plus 6 is 14. So I have n times 2n is 2n squared, and then n times the 14 is plus 14n. Now if you need an extra step for that, that's fine. All this is divided by 2. Well, let me just divide each individually by 2 to make it easier. So I end up with 170 equals n squared plus 7n, and I can set one side equal to 0. 0 equals n squared plus 7n minus 170, and I can split the middle term but shortcut this one. 1 times negative 170 equals negative 170. I want them to add up to positive 7, so the positive has to be the stronger one, so it's positive 17 and negative 10. And again, because this is a mnemonic quadratic, I can go directly to the factors. So I'm saying that 0 equals n plus 17 times n minus 10, which basically means that n equals negative 17 or n equals 10. Well, remember, n represents the number of terms in the sequence. You can't have a negative number of terms in the sequence. So I'm going to cross that one out and just say, okay, really, n equals 10 is the answer. So there are 10 terms. All right, the sum of the first n terms of an arithmetic sequence is 5n squared plus 17n all over 2. Find the first, second, and 100th term of the sequence. Okay, so when they're saying the sum of the first n terms of the sequence, that actually is just the series itself. So what we're saying here is actually Sn. So Sn equals 5n squared plus 17n all over 2. Now, to find the first term, well, if I add up all of the first term, that will be the first term. So S1 and A1 are the exact same thing because I just add up that one term. So that's the key why they asked us to find the first term first. So A1 is exactly the same as S1 because you're just adding up that one term. So plug in 1. 5 times 1 squared plus 17 times 1 divided by 2. 5 plus 17 is 22. 22 divided by 2 is 11. So the first term is 11. Now, I can't directly find the second term, but I can find the sum of the first two terms, S2. So I can do 5 times 2 squared plus 17 times 2 all over 2. So 5 times 4 is 20. 17 times 2 is 34. So that's 54 divided by 2. And of course, 54 divided by 2 is 27. But remember, that was the sum of the first two terms. So the first term plus the second term. So really what we're saying is that A1 plus A2, that's equal to 27. But since we already know what A1 is, it's 11, I can calculate A2 by substituting. So we're saying 11 plus A2 equals 27. Basically, A2 is now going to be 16 after we subtract. All right, so now we know what the first term is and what the second term is, and we were told from the beginning that this was an arithmetic sequence. So once we have that it's an arithmetic sequence and we know two consecutive terms, we can work out what the common difference is. So we know that D is just A2 minus A1 because it's the right minus the left. So 16 minus 11, which is 5. So now we can find the AN formula, which is A1 plus quantity n minus 1 times D. So in this case, AN is, A1 was 11, plus n minus 1 times 5. Now I can simplify that, although I really don't need to, but I'm going to go in anyway. So 11 plus 5n minus 5. So basically we're saying AN equals 6 plus 5n. And now finally we are asked to find the 100th term of the sequence. So a100 equals 6 plus 5 times 100. So it's going to be 506. So once again, what did we do? We were told what the sum of the terms of the sequence was going to be. So the sum of the very first term is exactly the value of that very first term. So A1 and S1 are automatically going to be the same. So we can work out what that very first term is just by plugging into this formula for S sub n. And then we can find out the sum of the first two terms by doing S2 and then calculate, again, plug it into the formula. And then once we know that, well, we know what the first term was. We just don't know what the second term was. So when they add them up, they become 27. So I can plug in the A1 is 11, A2 we don't know, and when we add them up, we know the answer is supposed to be 27. So you can calculate what A2 is. Now, because we were told it was arithmetic, that's sufficient for us to know what the common difference is, and then we can work from there to calculate the 100th term. And that is the end of the lesson.